Hello, and welcome to Computer Science and Scratch Programming. This is Chapter 1, Part 2, Introduction to Computers and Computer Hardware. I'm Brett Owens, and I'll be your guide. Our objectives for this lesson are to know the terms and definitions of computer bug, dumb terminal, Moore's Law, microcomputer and personal computer, and programming. To know the first commercially available stored program computer, and to understand events that took place between 1945 and the early 1970s as computers moved from being military and research university-owned devices to being business-owned devices. The Manchester Mark I and Harvard Mark I computers were two of the earliest stored program computers. These computers were developed in the mid-1940s and allowed multiple programs to be loaded and run on them. Prior to this time, computers were either number calculation devices, huge expensive calculators, or served a single purpose. However, changing programs on these devices, including the Manchester Mark I and the Harvard Mark I, was very, very cumbersome and took a considerable amount of time.
So we're in the Harvard Science Center, which is the crossroads of the Harvard campus. A lot of the science departments have their classrooms and offices in here. What's behind us here is the Mark I computer, which was an early electromechanical computer. So the Mark I computer is here at Harvard because Howard Hathaway Aiken, who was the person who conceived and designed the machine in collaboration with IBM engineers, was a Harvard professor of applied mathematics. And he wanted to relieve the labor of solving numerical equations by mechanical calculation that was done on pencil and paper. And what we have here is actually only a chunk of it. It was 51 feet long when it was all in one piece. It could do 3 additions per second. A multiplication took 6 seconds, and a division took 15 seconds. So this was a huge advance over doing things with pencil and paper, but it was slow work, and keeping the machine going all the time was a major feat of electromechanical engineering expertise. It was used for ballistics calculations, for calculating the trajectory of missiles. And it was also used for a little bit of the calculation in the Manhattan Project for determining the right parameters for the atomic bomb. So what you see here are paper tape drives. So the program was punched in paper tape and was on a loop. What you see there are registers that would correspond to the stored memory of the machine, which was only used for data. The program itself was fixed. These electric typewriters were used to print the output. These dials, which have 10 positions, are where you would insert the constant. So the program was fixed on paper tape, and if you had a constant, like you have in C code, you set some variable equal to a 47 at the beginning of your program, this is the equivalent here. You would dial in the number 47 on these, using these registers. The computational equivalent of this is much less than the smallest wristwatch computer that is now being produced.
On September 9th, 1947, Grace Murray Hopper, one of the programmers of the Harvard Mark I computer, noticed the computer was producing results that did not look correct. Upon inspection of the computer, she found on panel F, relay 70, a moth had gotten caught between the contacts. Dr. Hopper removed the bug and pasted it into the logbook, recording the first incident of a computer bug. A copy of this logbook and the actual bug is still on display at Harvard University's Science Center, where a portion of the computer is also displayed. Since then, many errors produced by the system have been referred to as bugs. There's a photograph of this bug to your right on the screen.
so much. Our first guest tonight has credits that are far too impressive for any guest on this program. This woman recently retired from the United States Navy as a Rear Admiral and was, until that time, the nation's oldest active military officer. She is also a pioneer in the computer field, as well as a brilliant and charming woman. Please welcome Admiral Grace Hopper. Grace, thank you very much for being here. A little messy, I'm sorry. Thank you very much for being here. Have you ever?
To be here.
Thank you. Have you ever seen this program?
I'm afraid it's too late for me. I have to get up at 5 to be at the office at 7.
You get up at 5 to go to work at 7?
Well, it's a long ways from Arlington, Virginia, across the river and down through Washington. We used to have a boat that went from the Pentagon down to the Navy Yard.
But-
Mr. Carter took it away.
Oh, President Carter.
Very sad.
What, did he commandeer it for private parties, or what?
No, he decided that it was using too much energy.
Oh, I see. It was a conservation measure. So then you're working a full day now for a private firm, right?
Yes, for
How-
Digital Equipment Corporation.
Digital
Got to
equipment?
get that in. They're a good outfit.
Okay. And how long ago did you leave active service?
31 August at 2400.
Now, see, that's...
It says the 2400 in the orders, too.
2400 is...
Midnight.
Oh, midnight, yeah. Was there a wild celebration at midnight when this took place?
No.
Yeah.
I was asleep.
You were asleep. So you went to bed in the service and you woke up out of the service.
Well, there's something you learn in your first boot camp or training camp. If they put you down somewhere with nothing to do, go to sleep. You don't know when you get any more.
I think that may be office policy for us upstairs, too.
Possibly.
Now, Grace, you mentioned boot camp. Now, when did you go through Navy boot camp?
1944.
44. And what kind
Up
of...
at Smith College.
Was it tough, physically demanding?
Mentally demanding.
Uh-huh.
All those youngsters that came in with me, they could still memorize things, and I'd forgotten how.
I see. So you...
You can't memorize you can't derive the organization of the Navy. You have to memorize it.
So you were older than most of the other
Yes,
enlistees or
I
recruits?
just barely got in. I was 37.
37. Now, what interested you about going into the Navy at 37?
Well, World War II to begin with. That's been one of the hardest things to tell the people in this country. There was a time when everybody in this country all did one thing together.
Yeah. And you just wanted to get over there and fight Nazis.
Well, the other thing, I had to go Navy because my great-grandfather was a Rear Admiral. And if I hadn't gone in the Navy, he probably would have risen from his grave and haunted me.
Yeah. So it's a tradition in your family. Yeah. And then, but before that, you also...
I was a college professor.
Yeah. And you worked on the original computer in this country, right?
I was very fortunate. The Navy ordered me to the first big computer in the United States, Mark I at Harvard.
It was called Mark I at Harvard? Now, in those days, the thing was...
51 feet long, 8 feet high, and 8 feet deep.
And that was the pocket model.
That's right. You could put it on a little tiny corner of a chip now.
Yeah. Now, how did you know so much about computers then?
I didn't.
How
I
did
was
you-
the first one.
Yeah.
In fact, I had to learn a lot of things. One day, Commander Aiken came around to my desk and says, "You're going to write a book." I said, "I can't write a book." He said, "You're in the Navy now." So I wrote a book.
You had to write a book, and that was outlining the entire...
Manual of the computer.
Yeah, yeah.
What a process.
Yeah. Now, I know nothing about computers, and you know everything about computers. They've called you
Not
the...
everything, all I can.
Yeah. But is there anybody who would know more?
Oh, I expect some of these good youngsters coming along know more.
But you're known as the queen of software. Is that right?
More or less.
Now, you know,
Quite a bit about that.
that conjures an image of somebody who has a lot of Tupperware parties somehow.
Well, I could give you a nanosecond.
Okay,
if you'd
now,
like
I see. I
one.
don't even know what that is, Grace.
Well, you see, we started with milliseconds, thousandths of a second, and then we went to microseconds, millionths of a second, and now we talk about nanoseconds. That's a billionth of a second.
But,
Well, they told me billionth of a second, and I didn't know what on earth they were talking about.
Right.
Didn't make sense to me. So one day I called over to engineering and said, cut off a nanosecond, send it over to me. And so I've got a bundle of them here, and you can pick your color.
oh, they come in color. See, I didn't
they come in
realize that
lovely
nanoseconds
colors.
now... In the old days, you only had your
I
choice
want
of white or gray, I think. Now, Grace, see, I understand that this is a visual
That is the maximum distance that light or electricity can travel in a billionth of a second.
No faster? No farther?
And when an admiral asks you why it takes so damn long to send a message by a satellite, you point out to him that between here and the satellite, there are a very large number of nanoseconds.
I guess so. All right, I tell you what, we have to pause here, Grace. We'll be right back. We'll continue talking about then we'd have to feed them dinner. Welcome back to the show. This is Admiral Grace Hopper. Is it Rear Admiral or just Admiral?
Rear Admiral, lower half.
What?
1 star.
Now, what does that term denote? Rear Admiral, lower half.
Same as a brigadier general.
But does the rear apply to is it a nautical term?
Well, it's Rear Admiral, Vice Admiral, and finally Admiral.
So it's just where he is positioned, he or she is positioned on the chart. Have there been any other female Rear Admirals?
There are 2 more. One's the head of Great Lakes Training, and the other's the head of the Nurse Corps.
But you were the first.
No.
You were not the first.
No. There were 4 or 5 or 6 ahead of me.
How many years did you have in the Navy?
43 and a half.
And can I ask you how old you are now?
I'll be 80 in December.
80 in December.
I think that's something to brag about.
Yeah, I would. Yes, sir. I don't blame you. Now let's take a look at this photograph. Tell me what this occasion was.
This was when I was promoted to Commodore, which later was renamed Rear Admiral.
I see.
And President Reagan did it all by himself. And when I met him, I have to explain, when I met him, I tiptoed up to him and got up on my toes and said, "Sir, may I tell you something?" And he looked at me funny as all get out, as if I was going to threaten something. I said, "I'm older than you are." He let out a laugh you could have heard all the way across the country.
Yeah. I'm guessing
He didn't mind at all.
He probably has not heard that much, has he?
No.
Take another second here and try to explain to me why a nanosecond means anything in computers.
The main reason it means something is because everybody wants answers, better answers faster. And you get them out of the computers, so you got to make the computers faster.
But this is as fast as they'll go.
And this is the fact as fast as they'll go. Now, of course, they've been talking about nanoseconds for several years, but now they're talking about picoseconds. And a picosecond is 1,000th of a nanosecond. Can you imagine cutting that into 1,000 pieces?
It's a 1,000th of a billionth of a second.
Yes. It's a quadrillionth of a second.
Yeah.
The best way to get them is
Quadrillionth
go to Wendy's or McDonald's or somewhere and get a small packet of picoseconds. They have the label pepper on them, but they're really picoseconds.
Picoseconds, I see. That's a good illustration. Have you had any difficulties making the transition from all those years as a military person to civilian life?
They should have a course in in civilian dressing. Here I've been wearing nice round-toed, flat-heeled shoes, and all of a sudden they want to put me on spike heels and I fall off. And I'm used to round toes and it's nothing but moccasins.
Yeah.
And then I tried to get some pantyhose. And the first pair bagged at the calf, and the second pair cut me in half, and the third pair did both. How do you get a pair of pantyhose that fit?
Well, I can tell you a little. I'll tell you a little later how you do that. You gotta work your way up to it. So Navy issue pantyhose were better than civilian pantyhose?
No, we don't wear pantyhose. I've got socks on.
Okay, so do I. Grace, I'm glad that you had some time to come up here from Washington and visit with us. It was a pleasure to see you. Congratulations on everything.
Question?
Sure, we have time for a quick question.
Is your ancestry Welsh, Scottish, or Irish?
You know, I'm not certain. I think it's more...
With your hair and eyes, I'd guess Welsh.
All right. I'm not going to argue with you.
I'm not going to make a joke out of that either.
Well, I don't know.
That's dead serious.
Is it a serious question?
Oh, it's very important.
Okay. What does that mean exactly?
Well, it depends on which kind of sense of humor you have.
Well, that's been lousy here lately. But...
I think it's done very well.
Oh, well, good. Thank you very much.
Thank you.
Is that it? Thank you, Grace. Nice to meet you. We'll be back, folks.
The following video is produced by the Computer History Archives Project, dedicated to the study and sharing of vintage computing technologies.
In 1956, Remington Rand introduced the UNIVAC 1103A scientific computer. The 1103A was a large-scale, high-speed, parallel, binary computer. It incorporated technological improvements over the previous ERA 1103 of 1953. The 1103A was built to meet the growing needs for high-speed computation and memory access required by government agencies and large institutions. The 1103A could perform 50,000 mathematical operations per second. The basic 1103A system used over 3,900 vacuum tubes, plus an additional 470 tubes in each memory expansion cabinet. A large installation could have nearly 5,000 tubes in total. The machine and its peripheral devices required between 1,000 and 2,000 square feet of floor space. It used punched paper tape for input and output, as well as magnetic tape. Up to 10 UNIVAC Uniservo tape drives could be connected. The machine could communicate with other machines via teletype communication circuits and other devices. A special feature was the hardware interrupt option, which allowed the operator to stop a running program and then restart it without loss of data or reprogramming. Early 1103A installation sites included Lockheed Aircraft Company Missile Systems Division in California, White Sands Missile Range in New Mexico, Wright Air Development Center in Ohio, the Operations Research Office at Johns Hopkins in Maryland, the Numerical Analysis Center at the University of Minnesota, and other locations both public and classified. The UNIVAC Scientific was a very powerful and reliable tool during the Cold War. Among its many other top-secret applications, it was used for simulation of surface-to-air missile systems and large-scale war game simulations. At least one UNIVAC scientific computer installed at NORAD was not decommissioned until June of 1974 during a technology upgrade. The system cost over $950,000 in 1956, which is over $8.4 million today. Early UNIVAC computers were highly desired by various government agencies due to their computational power and reliability. Remington Rand and its acquired companies, Engineering Research Associates, known as ERA, and the Eckert-Mauchly Computer Company, had assembled a powerful base of talented engineers and designers, making them a major player in government computing solutions.
Later, large corporations started purchasing these computers, and their basic architecture and design was prominent well into the late 1960s. This was truly the introduction of the computer age, where computers no longer were tied to universities and government research institutions. Over the next 50 years, the use of computers would grow tremendously in business and government. By the 1970s, Gordon Moore, shown to the right, co-founder of Fairchild Semiconductor and later Intel, theorized that processing speed of computers would double approximately every 2 years. His prediction has proven to be law. Although the control panel of a UNIVAC 1101, as shown on the right, fits on a desktop, it's important to remember that the full computer was still 20 feet by 38 feet and took up over 700 square feet of space. In addition, computers were very expensive, although contract amounts were kept somewhat private. Although we previously indicated contract amounts were kept private, we can determine the value of a computer at this time with the following information. A used UNIVAC was donated to Georgia Tech University in 1954, and the company showed its used value at $500,000, or $500,000. Converted to 2017 dollars, that used computer had a value of almost $4.5 million. Some people have estimated that to purchase a new UNIVAC in the 1950s, corporations and governments may have to shell out between $7 and $8 million. By the late 1960s and early 1970s, many people wanted to have their own computers, but found the cost was just not realistic. Small groups of individuals were working on dumb terminals like the one shown on your right, and attaching to large computers that existed at universities or their place of businesses. Dumb terminals are devices with which you can only enter data and display results. Dumb terminals have no ability to process information. Data is entered into the dumb terminal, travels through phone lines to the mainframe computer, is processed on the mainframe, and then the results travel back through those same phone lines to the dumb terminal, where the results are displayed on the screen. By the late 1970s, no major corporations were thinking about the concept of a microcomputer to serve a very small business or an individual. They had to be shown that such a product could be made economically and that there was a market to purchase these microcomputers. At that time, most people believed that less than 1% of all American households would ever have the desire to own a personal computer. Ed Roberts and Forrest Mims III, who just a few years earlier had funded a garage-based business in Albuquerque, New Mexico to build model rockets, expanded their business to include radio transmitters and calculators. Eventually, in January of 1975, they launched the Altair 8800 microcomputer. Kits for the Altair 8800 started as low as $439. The device shown on the right, as equipped, sold for around $2,500 in the mid-1970s. That's the equivalent of $12,200 today. This computer would eventually play a large role in the foundation of the Microsoft Corporation. However, we'll talk about that and cover more about that in Chapter 2. This concludes Chapter 1, Part 2. Next, we'll be discussing the emergence of Apple computers with the two Steves and the Homebrew Computer Club.